Hello everyone and welcome to today's webinar. My name is Brad Martz. I work in the Education Department here at NRCA. Today's webinar is a technical roofing industry update presented by Mark Graham. Mark likely needs no introduction, but I'll say a few words anyways. Mark has been in the roofing industry for 30 years and is the Associate Executive Director of Technical Services for NRCA, where he has been since 1993. His responsibilities include developing and implementing the association's technical positions, responding to inquiries for technical assistance, serving as the association's liaison with outside organizations, and developing and maintaining the association's technical publications, including the NRCA Roofing Manual. Before I turn it over to Mark, I want to point out the questions box on your control panel. You should see your control panel on the side of your screen. If you have any questions during today's webinar, you can enter them here in the questions box, and Mark will address those after his presentation. Mark, I will turn it over to you.
Thanks, Brad, and welcome everybody. Appreciate you spending the next hour or so with us. And in this particular presentation, I'm going to give an update on a couple of technical roofing industry issues we've been working on here at NRCA within the last couple of months. And I asked that we put this presentation in context with some of the previous webinars that we've done. In May of this year, I did a webinar as a part of this webinar series with NRCA and addressed the topics that are on the screen in front of you. Interestingly enough, that webinar, these specific topics, are pretty much still relevant. So I'm going to try to, for the most part, not get into and repeat some of these things that we've already discussed. And then also last year, we did 3 more detailed webinars on LTTR values, the energy code, and lightweight structural concrete. And like I said in the previous slide, the information on these past webinars is still just as relevant today as it was 6 months ago or a year ago. And just for a point of reference, if you're interested in any of these topics, past webinars and recordings of those are actually available on the NRCA website, so feel free to take a look at those if you have interest in those specific topics. And then also, if there's specific questions on these, I'd be more than happy to address these towards the end of this webinar. Also, in this month's issue of Professional Roofing Magazine, I did a little bit of a recap on some issues that we've dealt with in the past, trying to get readers up to date a little bit on some changes on some particular issues. In this particular article, I dealt with some changes in fire standards relative to rooftop PV, spoke a little bit about some water-based and LVOC adhesive issues, and then spoke a little bit about the manual. So we're going to get a little bit into this topic, or these topics today, and go a little bit deeper. So for today, I'm going to talk about what's going on with mopping asphalt in the industry, and actually some recent developments as recent as just last week. Talk a little bit about some concerns we have with steel roof decks, have some new information on water-based bonding adhesives, and then, like I said, at the end, be more than happy to deal with any questions you have on these 3 particular topics or anything we've talked about in the past. And as always, interested in new topics and things that you folks are seeing out in the field. So I'm going to start with asphalt. It seems difficult to believe in the roofing industry after all these years. We still have changes and developments in asphalt, but interestingly enough, we do. And like I said, as recent as last Wednesday, we had a pretty significant one. A little bit of background. The health and safety issues relative to the application of asphalt were really well established and defined in a document that was published in June of 2013. It's a NIOSH and Center for Disease Control document called Asphalt Fume Exposures during application of hot asphalt to roofs. Tom Shanahan with NRCA staff was influential and spent quite a bit of time in the development of this document. And the interesting thing about it is, even though the document is now about 11 years old, it is still the basis for how we deal with safe application of asphalt, asphalt fume issues, and protecting workers from the relative risks associated with dealing with hot asphalt. I think most people realize within the last 18 months or so, in May of 2013, the International Agency on Research and Cancer, in other words, IARC, published what's referred to as Monograph 103, and that deals specifically with asphalt at heated or elevated temperatures. The IARC monograph basically established that asphalt, heated asphalt, and specifically we're talking about oxidized asphalt, such as used in built-up roofing application, is categorized as a Group 2A. In other words, the product is probably carcinogenic to humans. This is a culmination or a report of a very detailed long-term study dealing with heated asphalt and the risks associated with it. Relatively long report, and I'll be real honest with you, a little bit of an excruciating read, very highly technical, highly scientific. But actually 5 pages specifically deal with roofing workers and their exposure to bitumens. So like I said, the IARC group has decided to categorize asphalt as a Group 2A, which is a significant finding for the industry. It has the potential to trigger new regulations, new standards, new health and safety guidelines, but interestingly enough, to date, we still have not seen new regulation coming out of the publication of this document. And like I'm saying on the screen, I want to kind of note yet, because we haven't seen new regulation yet. That doesn't mean we won't in the future. It's just interesting at this particular point in time, the IARC determination hasn't triggered new regulation. But that Group 2A classification is relatively significant to us in the industry. Over the years, NRCA has done a relatively large amount of asphalt testing, where we actually go out in the field and procure asphalt either at the point of application or somewhat in the procurement process. And we've actually been doing this since the early 70s. My predecessors, a gentleman by the name of Edwin Mertz and Bill Cullen, have done quite a bit of research in this area. And in the context of what I'm presenting today, I'm going to use some 1989 data developed by Bill Cullen as somewhat of a baseline. And in '89, NRCA and Bill Cullen collected 26 asphalt samples, and the asphalt was tested for its equiviscous temperature, or in other words, its preferred application temperature. And you can see the values in on the screen in front of you. To give you a little bit of perspective, back probably about 8 or 10 years before this study, I actually spent some time as a roofing mechanic, actually doing roofing work and mopping and things along that line. And in the 82, 83 time frame, we were looking at EVT temperatures for Type 3 asphalt somewhere in the range of about 375 to about 390 degrees Fahrenheit. So the point to be made is, over time, up till 1989, we saw a little bit of a slight creep in EVT temperatures upwards. So that's a baseline point, as I mentioned. NRCA did similar testing in 2000. This particular year, we tested 19 different lots of asphalt. And you'll notice the EVTs between 2000 and 10 years previous stayed substantially the same. A little bit of change in values, 5 or 10 degrees, but nothing significant. I do want to point out to you, though, something that was surprising to us in the 2000 study was the elevated temperature of asphalt's flashpoints. At this point in time, the ASTM standard for asphalt was calling for a minimum flash point of 500 degrees Fahrenheit, and we were comfortable that most manufacturers were meeting that. But by 2000, we were actually measuring flashpoint temperatures on asphalt that we were getting out in the field as high as 640 degrees. So that's a relatively significant finding, because the rule of thumb in the industry at that point is you could heat asphalt in a kettle or tanker up to 25 degrees below its flash point. So if you have a 640 degree asphalt, conceivably that asphalt could be heated in the field up to about 615. The other significant finding from this 2000 study was that when we tested the asphalt samples that we procured, 10 of the 19 actually did not comply with the product standard ASTM D312 for asphalt. And that was a little bit startling for us. In other words, some of the physical properties got a little bit out of whack. Typically hardness or relative softness of the asphalt was either high or low relative to the standard. And that was surprising to us because we were pretty comfortable prior to that that asphalt was in sync with the standard. This past year, we have repeated that testing, and we've tested 14 different lots of asphalt from 7 different suppliers from around the U.S., and the EVT values are in front of you on the screen, as well as the flash points. What I want to point out to you is the EVT values have crept up roughly about 35 degrees, in some cases a little bit higher than what we saw 12 years previous. And that was an interesting finding to us. Also, the flash point temperatures have also continued to creep up. So this time when we tested these 14 lots of asphalt, we're seeing flash points in the 615 to 660 range, which is significantly high. And I mention that because now we're in a context where the NIOSH Center for Disease Control document is telling us be careful, be watchful of elevated temperatures with asphalt. The IARC document is definitely saying be watchful of elevated temperatures in asphalt. Yet the asphalt we're getting in the field is basically lending itself to higher or relatively higher heating than what we did 10, 12, 15 years ago. So that's a relatively significant finding to us. And the ultimate concern is that the guys in the field, by the ability to overheat asphalt, are actually doing just that. So instead of, say, 20 or 30 years ago where a kettle would be at 500, 525 degrees, we're seeing kettle temperatures or tanker temperatures now in the high 500s or in some cases low 600s. And that is totally counter to the concept of what is trying to be portrayed in the IARC document and in the NIOSH CDC document. Also of concern is the asphalt we're testing today is not faring well relative to the ASTM standard. Actually 10 of 14 were actually outside of spec, and that is typically with being the asphalt as being too hard, or having penetration values outside of those allowable within the ASTM standard. And interestingly enough, that actually correlates to the higher flash point temperatures and higher EVTs. At the same time all this is going on, I want to point out that the ASTM standard for asphalt still says a minimum flash point for asphalt should be 500 degrees. And that's what we are seeing on most asphalt suppliers' product packaging, markings, things along that line. So we actually have some asphalts that have EVTs higher than their labeled flash point temperature, which is just totally counterproductive to, well, A, common sense, and then B, good roofing practice. Because what we do have to acknowledge in the industry is that there is some temperature drop in asphalt between the kettle or tanker and the point of application on the roof. And flash point out in the field of the roof is a kettle temperature or tanker temperature, and EVT is a temperature at the point of application. There is a temperature drop in between. And when we have EVTs and flashpoints overlapping or getting very close to each other, that becomes an asphalt that is, for all practical purposes, not feasibly installable in the field. In May of this past year, NRCA issued an industry update on this specific topic, dealing with the health and safety issues and explaining some of the asphalt testing that we've been doing and how values have kind of changed or crept up over the years. And in this document, as you can see in the call-out on the front page, NRCA and ARMA have proposed a revision to the ASTM standard, ASTM D312, to deal primarily with the health and safety issues. In other words, hopefully get to the point where we're not heating asphalt as high, but then also dealing with the application issues. In other words, a temperature differential between Kettle temperatures and EVTs. Just last Wednesday, a new revision to the ASTM standard for asphalt, ASTM D312, was approved at an ASTM meeting in New Orleans. And that standard will be published, that revised standard will be published probably within the next several weeks, and it will be given the designation ASTM D312, which is a standard designation, -15, and the -15 indicates the year or addition date. One of the key points in this new revision of the ASTM D312 standard is a requirement that the maximum field heating temperature for asphalt, whether it be a kettle or a tanker, be 550 degrees Fahrenheit. And then that corresponds to a minimum flash point for the asphalt of 575. And that is a relatively significant change from the previous edition of the standard that had a flash point minimum of 500. So in a sense, the standard is permitting a higher flash point, which may be construed as being counterproductive, but actually what we're doing is providing a maximum heating temperature, kettle temperature, or tanker temperature, that is probably notably lower than what is currently listed or what we're currently seeing in the field. So that is one of the means we're using to address some of the health and safety issues associated with asphalt. Also, for the first time, the ASTM standard will reference or have specific maximum EVT values, in other words, point of application temperature values, and specific values are provided for both Type 3 and Type 4 asphalt and mop and mechanical spreader applications. You will notice these values are relatively significantly lower than what we are dealing with in the field currently. I think our average Type 3 asphalt EVT value for what we're testing right now or several months ago was about in the 460 to 480 range. The new standard is calling for a 430. In other words, what we're doing is providing a differential between EVT temperatures and that maximum heating temperature. And then finally, we want to get back to where the industry was probably about 20 or 30 years ago and get away from pre-printed package labeling that says something to the effect that the EVT of an asphalt is within a range of temperature. What the new standard is calling for is actually lot-specific package labeling of asphalt EVT. And like I said, this is the new standard, just published or just finalized last Wednesday, and published as of the 2015 edition of the ASTM standard. So when it comes to asphalt, NRCA has some recommendations. First off, we recommend you seek out asphalt complying with the new edition of the ASTM standard. Not only should we get to a point where we have lower kettle and tanker temperatures, but then also lower EVT temperatures with an adequate spread for proper installation. And that standard is specifically designated as the -15 edition, so that's something you're going to have to look at. I'm sure we're going to have some manufacturers that make that change a little bit quicker than others, or put another way, we're going to have some manufacturers that lag. What we're asking you to do is seek out asphalt that complies with the new edition of the standard. Secondly, we suggest you consider asking the asphalt supplier for a certificate of compliance, and that is a lot-specific documentation of the physical properties of that particular asphalt. Virtually all asphalt suppliers are actually providing certificates of compliance. They're actually being tested and run in the background. It needs to be done for approval testing and code compliance and things along that line. But the certificates very rarely find their way to specifiers and contractors. So we ask that you ask for them, and the wording, the request you would make on a purchase order contract or specification is certificate of compliance specific to the asphalt lot in which you're dealing with or what is delivered to the job. The next point I think is fairly straightforward. We want to get away from overheating asphalt any hotter than it needs to be, and at a maximum, the new Kettle temperature for asphalt is 550 degrees Fahrenheit. Again, we are of the opinion that we're actually lowering Kettle temperatures in the field, and the revisions to the new ASTM standard allow us to do that, which is significant for us from the health and safety standpoint. Next point is something we've been preaching at NRCA for more than 40 years. For built-up roofing application, apply asphalt at its EVT temperature. And I think the last point on asphalt I want to make is make the guys in the field aware of what's going on. The asphalt that you're going to be seeing here in the next couple months is not necessarily the same asphalt, same physical properties, same flashpoints and EVTs than the field guys would have seen, say, for example, 6 months ago. And a lot of our moppers out in the field have a few years of experience. They might have been in the business 10 or 15 years ago. The point to be made is tomorrow's asphalt is not the same as yesterday's asphalt, and it's certainly not the same asphalt as these guys were trained on. So make the field guys aware that there are changes in asphalt, and the intention with these changes is to lower Kettle temperatures and then ultimately lower EVTs, which should help out pretty significantly on the application side. And as always, if you have any questions or comments or see issues with asphalt or getting some pushback from asphalt suppliers, please feel free to contact us. That's basically one of the primary reasons that we're here, and we'd like to get involved or help if you have questions or specific issues. Next, I'm going to change directions and talk a little bit about some steel roof deck issues. And it's kind of surprising that at this point we're actually having issues with steel roof decks. Over the years, we've dealt with some corrosion issues, and hence NRCA has recommended we shy away from prime-painted steel roof decks. We use galvanized steel roof decks. But the steel deck issues have been relatively quiet until the last couple of years. And what we're doing now is taking a look at actually deck design, steel deck design, relative to roof system design. And interestingly enough, there is a disconnect, if you pardon the play on words. Steel decks are designed differently than roof systems, and when you put the two together, we have a potential that steel decks may be under-designed for wind uplift in some cases. In other cases, specifically with seam fastened mechanically attached single plies, we have situations where the roof system may actually be overstressing the steel roof deck. In a sense, what we're saying is the roof system is relatively stronger than the steel roof deck in imparting overstress on the deck, and that applies specifically in seam fastened mechanically attached systems. I'm going to show you an example in just a minute. And then we also have structural overload situations, particularly with some seam fastened mechanically attached single plies at design load conditions, and I'll have an example of that also. When it comes to steel roof decks, designers, and when I say designers, we're probably talking about a structural engineer who's working on a subcontract basis for a project architect, they pretty much rely on one of two documents. The Steel Deck Institute's Design Manual for Composite Decks, Form Decks, and Roof Decks, or more recently, a standard called ANSI SDI RD1. And the standard is actually titled the Standard for Steel Roof Deck. These two documents are what the structural engineer is likely using to design steel roof decks for buildings. And these are the particular documents that were applicable for buildings designed prior to 2010. And the language relative to roof uplift in these documents says, design the steel roof deck for a 30-pound uplift, and 45-pound uplift if you're involved in a roof overhang or a cantilever condition. We design roof systems typically for loads notably higher than this 30-pound uplift. If you're going to deal with a factory mutual rating above a 1-60 classification, we have a situation where the roof design is out of sync with the steel roof deck design, and that is the inherent concern here. More recently, the Steel Deck Institute has updated their RD1 standard, and the standard now basically includes the same language, but the wording, but not less than. In other words, theoretically, steel roof decks should now be designed for true design loads. But the point to be made is the documentation, the design practice, the tables in the Steel Deck Institute manual and the SDI standard are based on 30-pound uplift. And that is a disconnect or a difference from what we use in the roofing industry. Also, SDI has issued a bulletin that deals specifically with attachment of roof membranes to steel roof decks. And the bulletin mentions a couple of points, that decks are typically designed with joist spacing somewhere between 5 foot and 6 foot 8 inches on center, and steel deck designs are predicated on the assumption that the deck is loaded uniformly by the roof system. And by uniform loading, I'm talking about, for example, a fully adhered system, fully adhered single-ply, built-up, modified, something along that line, that doesn't deal with seam fastening like we deal with in mechanically attached single-plies, where we might have 6 foot, 7 foot, 10 foot, 12 foot spacing. Because the loading on the deck is significantly different in a seam fastened system versus a uniform loading situation. The SDI bulletin gives two scenarios, and the one I have depicted here is where we have a seam fastened single ply installed on a roof deck perpendicular or across the flutes of the deck. In other words, the seams are running parallel to the bar joists. And SDI has indicated this results in a moment in excess of 3.8 times, or a load in excess of 2 times that of what would occur in a uniform loaded system. The number 3.8 from the structural engineering standpoint is beginning to be a bit of a concern for us, because while we have excess capacity in steel roof decks, we have safety factors and things along that line. By the time we're adding moment to a deck by the factor of 3.8, we're getting out there to the point where we're concerning ourselves. The other scenario which SDI has created is those situations where the seams in the mechanically attached single ply run parallel to the deck. In that particular case, SDI is indicating the deck is exceeding its bending moment in shear by a factor of approaching 12. And from the structural engineering standpoint, when we see numbers of that magnitude, we're doing something to a deck 12 times more than what we expected. We have a relatively significant issue on our hands, and something to concern ourselves with. And part of the problem with the scenario is we have a disconnect in the design community. the people that are designing roof systems are not necessarily privy to what the steel deck design person did. And on the other hand, the steel deck designer probably has no idea what type of roof system is going to be going on a roof. We just make assumptions. The deck designer is assuming the roofing designer is installing a uniform system, and then vice versa. We're assuming that the steel deck designer is just anticipating whatever loads that we're going to apply. So there is a disconnect. And the SDI bulletin concludes that SDI is not recommending the use of what I'm going to refer to as seam fast and mechanically attached systems without that deck being signed off by an experienced structural engineer. And that is a pretty significant, a pretty bold statement for the roofing industry. At the same token, what concerns me is SDI really nowhere in their documentation is explaining to designers how to design for mechanically attached systems. So they're cautioning in recommending the use of a structural engineer, but nowhere are they explaining what the structural engineer should do. There really is no guidance. So as far as NRCA's recommendations at this point, I'm going to ask you to be aware of the situation. There is obviously some potential liability here, and as roof system designers, we should not rely on any excess capacity that is in steel roof decks. We should be basically designing by the book. We should be designing based on the yield strength and modulus of the steel roof deck, and that's what's pretty much dictated by the SDI manual. I also recommend everybody in the roofing industry be cautious of accepting responsibility for the roof deck. You really can't look at a steel roof deck and tell how it's been designed, what type of load capacity it has been, and I think the last thing we want to do is being accepting of somebody else's responsibility, but also signing off on something that we're not necessarily privy to all the necessary knowledge. The National Roofing Legal Resource Center, or NRLRC, as I indicated on the slide, has some recommended proposal and contract language that I recommend contractors use in proposals, contracts, purchase orders, things along that line. And that contract language says just that. You know, a roofing contractor is capable of looking at a roof deck, telling if it's true and straight, telling if the surface of it is relatively dry, but as roofing contractors, we're not necessarily structural engineers that know all the knowledge that needs to be known on steel decks. And finally, better communication is clearly needed between roof system designers and deck designers. And when I say better communication, I think I'm probably being a little bit polite there. There should be communication, period, because there appears to be very little communication currently between the person designing a steel roof deck and a person designing a roof system. So again, the bottom line point here is be cautious, be aware of the situation. For the contractors, I would encourage you to let your project managers and estimators know about this situation. For the designers on the call, there's a bit of a challenge for you, and quite frankly, some of the communication challenge has to fall with the design community. We need to communicate better between roof system designers and deck designers. Next month in professional roofing, my Tech Today column will deal with this issue pretty much in detail. So feel free to refer to that once it comes out after the first of the year. And then also feel free to pass this on. Contractors, pass it on to designers. Roof system designers, pass it on to structural engineers. And use the column, use what I've written, use the information NRCA is providing to start some of that communication. Okay? Next, I'm going to change directions and talk about some continuing issues, some continuing concerns we have with water-based bonding adhesives, particularly this time of year, pretty much throughout the country. They're providing challenges to us in the field. In August of 2012, Maciek Rupar of our technical staff did what I think is a very good article explaining why the regulatory community has basically forced manufacturers into the concept of lowering VOCs with adhesives, which has gotten manufacturers into the position where we're using water-based adhesives. I want you to realize that this is a result of basically a regulatory and a green sustainable push. It's not necessarily something that manufacturers wanted to do because they think it was a good thing for the industry. Manufacturers are being pushed towards water-based bonding adhesives, and it's creating problems for us out in the field. In December of 2013, my column dealt a little bit with cold weather applications and some of the struggles that are out there with water-based bonding adhesives. For example, manufacturers are saying storage temperatures should be between 60 and 90 degrees Fahrenheit. Installations should only be conducted when temperatures are 40 degrees and rising, and realize green time with water-based adhesives are longer, in some cases significantly longer, than they were with solvent-based adhesives. Coming out of this, NRCA's recommendation is, first off, don't let your adhesives freeze, because once a water-based adhesive freezes, there is no amount of mixing that's going to turn it back into something that's usable. And we raised the concept that instead of a specific temperature limit, the issue that we're concerned with is actually the issue between the amount of moisture in the air and the ambient temperature. And in consultation with several manufacturers, we arrived at a recommendation for a minimum of a 5-degree differential between ambient temperature and dew point. Over the last 18 months, NRCA and MRCA have done quite a bit of testing on water-based bonding adhesives, and as I look at this program of testing, it is actually one of the largest testing programs NRCA has ever been associated with, and we thank our friends at MRCA for their contributions and technical assistance in the program. One of the things we found in the testing program, where we've tested various manufacturers' water-based adhesives, is that manufacturers' products vary, and in some cases vary relatively significantly. So the guys in the field need to realize manufacturer A's water-based adhesive might be an entirely different concept, handling issues, chemistry, everything else than manufacturer B. There's significantly different water-based adhesive products out there in the industry. Another thing we've discovered is that the pails, in other words, a particular manufacturer's adhesive, manufacturer A's adhesive and their product name XYZ, we found variability between individual pails, in some cases, in the same lot of that same adhesive. In other words, what the guys in the field are forced to deal with is somewhat of a moving target. There are some consistency issues. Strength development time, in other words, the amount of time where an adhesive is going to grab, were significantly longer than what was represented to us, and significantly longer than what we expected compared to low VOC adhesives and solvent-based adhesives. And the length of time is a concern. I mean, we are dealing with, in some cases, weeks as well as, in some cases, a month before we develop strengths that we saw with other adhesives in a matter of hours or a matter of days. So a significant finding. And also for water-based adhesives, particularly when applied to paper-faced polyisocyanurate insulation, we found peel strengths to be relatively low, in some cases troublingly low. So we have a peel strength issue with water-based adhesives up till the time the adhesive develops its full bond strength. And like I said, that could be a matter of days, weeks, or in some cases approaching a month, which is a concern for us. Different manufacturers are taking different approaches. Sika Sarnafil, for example, has published now for several years and distributed what they refer to as a blackout map. In other words, they're saying if you're in the blackout region, we are not going to ship water-based adhesives, their 2121 adhesive, to that particular portion of the country. The implication is don't use water-based adhesives during these particular dates in these particular regions of the country. And what Sika Sarnafil is saying, for example, this time of year, their water-based adhesive should only be used in Zone 4, which is a very narrow portion of the most southern region of the country. So that's how Sika is dealing with it. Manville, on the other hand, is taking a little bit more of a narrative approach, and they also have shipment restrictions between October and April, depending on where you are in the country. And the bottom of the bulletin kind of shows the map. Also has temperature storage limitations, and also some guidelines when water-based adhesives just should not be applied. For example, temperatures under 40 degrees, when the relative humidity is high, when there's not an adequate dew point temperature or dew point separation, and when the temperature and the dew point will converge upon themselves within 6 hours of installation. And also if there's going to be a temperature drop below freezing within 48 hours after installation. In other words, temperature and humidity become key factors in when a water-based bonding adhesive should be used and when it should not. Now, I'm calling out both Sika and Johns Manville because I think they're being relatively open and relatively detailed in what their recommendations are, not only to contractors, but also to the design community and users. Most other manufacturers are providing some type of an installation parameter or installation limitation that is putting the foreman or the guy on the roof in control of when a water-based adhesive should be used or not should be used. And NRCA's opinion is that decision needs to be taken out of the foreman's hands. That should not be a foreman's decision when to use one product versus when to use another product. His job is to direct his crew to install products. Decisions on product selection, what to use, and things along that line should be made somewhere further up in the design community, whether that be higher up in the contractor's organization, or the designer himself should be making that determination. In other words, a designer not considering the water-based bonding adhesive limitations shouldn't be pushed down, or that decision shouldn't be pushed down for the foreman to implement. And I think we're in a situation where Manville and Sika Sarnafil has been a little bit more forthright with the industry than other manufacturers. I'll also mention that this all gets terribly complicated very quickly. And an interesting thing that Manville has just come out with is actually a smartphone app which pretty much explains the limitations in their bulletin, but does so in a app type format. So this is actually a screen capture off of Manville's app, and I did this at the NRCA convention last week, interestingly enough, when a Manville representative was speaking on this particular issue in Grapevine, Texas. And the application basically goes out to the internet and picks off the address or the specific location based on your GPS coordinates, and it goes out to the weather sites and gets a temperature and relative humidity value. And then in the background, the app is actually providing a flash time estimate of how long that adhesive, water-based adhesive, is going to take to flash off. And as you can see, in Grapevine, Texas, when it's 62 degrees Fahrenheit and 89% relative humidity, which is relatively high for that time of year, Manville is saying that it's going to take over 2 hours for that water-based adhesive to flash. And that number will vary based on temperature and relative humidity. Interestingly enough, I checked just this morning and hit the app for here in Chicago, where I'm located, and our temperatures were in the high 20s, relative humidity of 81%, and the app is just coming right out and saying water-based adhesives will not flash off under these particular temperature conditions. And again, I want to get the industry to the point where we're not leaving this decision in the hands of the foreman. The designer should be taking this into consideration and not pushing decisions back on the foreman. So for some interim recommendations, manufacturers clearly need to take a more active role in educating contractors, senior personnel, and also designers on when it is practical or not practical to use water-based adhesives. Designers also need to consider these issues. If you're designing a roof and you want water-based adhesives, you pretty much have to write off an installation this time of year. Or if you're in a situation where there may need to be an installation this time of year, offer alternatives within the spec or the design. In other words, if this job is going to fall in November, December, January, instead of water-based adhesives, let's do this. I'd much rather those decisions lie with designers and contractors, senior office personnel, instead of with foremen. Designers should consider specifying Class 2, in other words, glass-coated facers, when using water-based adhesives. And that is something coming out of the joint NRCA-MRCA testing on water-based adhesives. We're seeing those peel strength issues with paper-faced ISO. In other words, the water in the water-based adhesive is having an impact on the facer sheet. The way to address that is to not use a paper-faced facer. If you use a coated glass facer, in other words, what's referred to in the ASTM standard for ISO as a Class 2 facer, we don't have to be concerned with those peel strength issues because we're not seeing facer degradation as a result of the water in the adhesives. So we're recommending designers specify Class 2 polyiso facers when using water-based adhesives. It's a situation where the paper facer that we're typically using in ISO is a limiting factor for us, and we recommend you get away from that. Finally, make field crews aware of the limitations. The points in the Manville Bulletin, for example, temperature, humidity, dew point, and things along that line, are good for the field guys to know, and those recommendations may vary slightly between manufacturers. But make the field guys aware that there is a point where these things are just not going to work, and that is somewhat common this time of year. So make the guys in the field aware of the situation. But like I said, I want to get away from the situation where we have the field guys making decisions whether they can use the product or not, or have to switch it to somebody else. That shouldn't be their call. And finally, consider alternative products or systems. Again, if you need to install a system with a water-based adhesive because of regulatory or specification issues, that's fine. But if that installation is going to occur this time of year, you're going to have problems, and have alternates or maybe completely different roof systems available to you so you can complete the installation, and then, of course, have that be signed off by designers and through the contract process as need be. So with that, I'm going to wrap up, turn the microphone back over to Brad. We can go through a couple of questions if you like. And like I said, more than interested in questions on these particular topics, or if you want to talk about something we've dealt with in the past, we can do that, or something new, that's fine also. And finally, I'm just going to put the screen up with my contact information. Please feel free to contact me. Any questions or comments, it's always good to hear from everybody. So Brad, back to you.
All right, thanks, Mark. We do have some questions that have come in. As Mark answers these questions, feel free to continue entering your own into the questions box on your control panel. First question, Mark, is what caused the increase in EVT and flashpoints?
EVT and flashpoint increases were basically a conscious decision by manufacturers to do a couple of things. I mean, one of the things that manufacturers want to do is to eliminate kettle fires. And one of the easiest ways to do that is to push up flashpoints. There's also a little bit of a push in the industry to raise EVTs because we reduce or potentially reduce membrane slippage relative to temperature. So there is a couple of legitimate reasons for attempting to increase EVT and kettle temperatures, but we do have to put that in the context with the health and safety issues, where we don't necessarily want to overheat or excessively heat asphalt higher than what is deemed necessary. And it's interesting. We sat down with the asphalt roofing manufacturers and the key asphalt suppliers pretty much throughout the country, and the realization is that 1989 set of values that Bill Cullen tested is a happy medium in between dealing with high EVTs, high flash points, and something that's workable in the field. And that's what the industry has basically gravitated towards, moving the industry back to 1989 values when it comes to asphalt. Good question.
Okay, next question is, will asphalt changes for BUR systems affect shingle manufacturing products, or do the two not affect each other?
There is a potential for there to be some correlation, because what we're dealing with is basically crude oil from its purest sense. But the point to be made is the asphalt that's actually going into, for example, a built-up roofing application is actually different asphalt. It's a little bit different philosophy than asphalt that goes into an asphalt shingle or asphalt that goes into a modified bitumen sheet. For example, a asphalt shingle asphalt is mixed with stabilizers, fillers, things along that line. In other words, the shingle guys can change physical properties by doing things other than just raising an asphalt splash point, EVT, hardness, things along that line. So they are related, but they're not necessarily directly related.
All right, next question is, it would seem to ensure less stress on roof decks, you should ensure single ply is installed perpendicular to deck flutes. Would that be a good rule of thumb?
In the general sense, it is a good rule of thumb, and that's pretty much what most manufacturers' installation instructions are dictating, suggesting, things along that line. But as we do perimeters, as we do corners and things along that line, we do get ourselves in the position where at some of the highest wind load situations on the deck, we are doing some installations of half sheet or something along that line parallel to the roof deck. And the concern there is the situations where we see the highest roof loads, wind uplift loads, are also some of the situations where we might not necessarily be running the half sheet in the most optimum direction. So I agree with the premise in the question. It's just that we don't absolutely do that entirely throughout the entire roof. But perpendicular to the deck flutes is the general recommendation of the industry.
Okay, thank you. Next question is, in a water-based wet lay-in of TPO, what are the causes of membrane blistering?
Well, that's a complex question, and I'd actually have to know more about some of the background on that. So I'm basically going to ask that questioner to contact me directly, and I'll get into that. But there's any of a number of factors. I mean, too much adhesive, the adhesive not flashing off properly. There's potentially some membrane issues. There's a whole myriad of factors that are possible there. So I just ask that we follow up on that one.
All right, and to the person who asked that question, Mark's email address is on the screen there. The next question is, we are seeing a fair number of instances and associated lawsuits in California stemming from condensation under cool roof membranes. Is NRCA getting similar reports from other areas of the country?
The issue of condensation under quote-unquote cool roofs is something that's relatively common. We've actually done some research, and actually I think I've written on it a number of times. We've seen those types of scenarios all the way as far south as hot, dry desert climates. Let's say, for example, Phoenix. I've dealt with this. I dealt with a phone call this morning in northern Maine of a similar situation, condensation under cool roofs. So to answer the questioner's fundamental questions, have we seen it in places other than California? We've seen it pretty much throughout the country.
Okay, well, those are all the questions that have come in up to this point. Again, Mark's contact info is on the screen there in front of you if you think of something after the presentation. Actually, we have another comment that came in, it looks like. Gentleman said, we have witnessed several white single-ply roofs that have several round spider webs cracking in the membrane. So the question is, do you have a solution to this?
Round spider web cracking.
So several whites.
At least in my visualization, what's being represented there is some type of a impact, whether it be an atmospheric hail type impact or potentially mechanical impact, HVAC guy dropping tools and things along that line. I mean, membrane thickness, membrane reinforcement, a more rigid, stiffer cover board are ways of avoiding that in the future. You will notice each of those solutions I just mentioned pretty much dictate re-roofing or things along that line. Once you do get yourself into a cracking situation with a single-ply system, I mean, potentially it could be localized coating could be used, repatching the spider cracked areas if they're relatively small. But you basically got to go back and find the root of the problem and hopefully design yourself around it. There is no magic bullet or magic fix to it.
Yeah, the question that actually ended up coming in was, is that issue caused by hail? So I think you did answer his question that it could.
It could be hail. It could be other form of impact. It depends on how widespread it is on the roof. But usually, if I'm envisioning what's being represented here is round spider web type of cracking, it definitely is an impact. Whether it be hail, that would take a field look at what's going on in the field.
Okay, another question. Is stone ballast ever allowed anymore? The inverted roof membrane assembly roof, if that makes sense. Sorry if I butchered that.
No, that's fine. I was just in Denver yesterday doing a presentation to the Colorado Roofing Association, and interestingly enough, ballasted systems, stone ballasted systems, are still popular in some markets. Denver is one of them. Was with some folks in Milwaukee last week. Same thing up there. So it depends. It's a very geographic situation. I mean, in the hurricane-prone regions and the coastal areas of the country, it seems like the industry has kind of gotten away from ballasted systems because of the wind and airborne debris issues. In other areas of the country, particularly in the center portion of the country, some particular markets are still using quite a bit of ballast. The question was, I think, specifically focused in on protected membrane roof systems or inverted roof systems. That's a relatively niche market, and we're not seeing those as much as we used to maybe 10 or 15 years ago. But they're still out there in certain installations, and if done right, I still think that an inverted roof system, protected membrane system, is a good roof.
Okay, we do have time for one more last question that came in. The question is, would Rhinobond solve the problems between mechanically attached and water-based adhesives? Can you comment on its effectiveness?
Well, that's kind of a loaded question. From the steel deck standpoint, Rhinobond puts us somewhere in between wide seam spacing, mechanically attached systems, and uniform deck loading, like the Steel Deck Institute thinks the roofing industry always provides. So I think Rhinobond is a step in the right direction. But potentially we still do have deck overstretch issues because we are concentrating load at specific fasteners. That would really have to be something that's taken a look at in a little bit more detail. But I think it is a step in the right direction. As far as the water-based bonding adhesive issues go relative to Rhinobond, well, if we don't have to use water-based bonding adhesive, that is correct. We're not going to have water-based bonding adhesive issues. But even in a Rhinobond system, we're still going to be installing flashings. We're still going to be adhering flashings at perimeters and corners and penetrations and things along that line, and that would be a concern to me. But it would eliminate the problem in the field of the roof because, like I said, if you're not using water-based bonding adhesive, you're not going to have a water-based bonding adhesive issue. So the quick answer is yes, to a certain extent.
All right, we have reached the top of the hour, so thank you, Mark, for this helpful update today. A few notes before we close. This webinar is eligible for AIA and RCI CEUs. So if you're interested in receiving credit, please email nrcawebinar@nrca.net. So email nrcawebinar@nrca.net if you're interested in CEUs. Also, a video recording of today's webinar will be posted in the NRCA online bookstore in the coming weeks. And lastly, we encourage you to join us for next month's webinar as well, in which the topic will be Top 10 Employment Mistakes Made by Contractors. You can register for that webinar and future webinars at www.nrca.net/webinar. And that's also where the video recordings are posted as well. So with that said, thank you, Mark, again for your presentation today, and thanks to all of you for joining us.
Thanks, everybody. Have a great holiday and enjoy some downtime.